Hi guys, today we're going to be going over USACO mowing the field. So in this problem, Farmer John is really bad at mowing the grass in an orderly, logical fashion. So his farm is a 2D grid of square units cells, and Farmer John starts in one of these cells at time 0 and mows the grass so that it is initially the only cell in which the grass is cut. So, Farmer John's remaining mowing pattern is described by a sequence of n statements. So, for example, if the first statement is W10, then for times 1 through 10, basically Farmer John will step one cell to the west, mowing the grass along the way. And after completing the sequence of steps, he will end up 10 cells to his west at time t equals 10, and he's mowed every single block of grass along the way. So Farmer John's progress is super slow, and basically some of the grass that he mows might grow back before he's finished with all the mowing, and any section of the grass that is cut at time t will appear at time t plus x. So Farmer John's mowing pattern might have him revisit the same cell multiple times, but he remarks that he never encounters a cell in which the grass is already cut. So that is basically every time he visits a cell, his most recent visit to that same cell must have been at least X units of time earlier in order for the grass to have grown back. So what we need to do is we need to determine the maximum possible value of X so that Farmer John's observation remains valid. So this might seem tricky because it says the maximum value of X, but we're actually finding the minimum value that it can be. Because obviously, let's say that we have Farmer John visit square X, and then he revisits square X 24 time units later. Then obviously then that means that the answer for now is going to be 24. However, let's say that in the same test case, Farmer John visits square y and then revisits square y 10 time units later. Then are we going to choose 24 or 10? We're going to choose 10 because if we chose 24, then that means that the scenario where we revisit square y 10 time units later, the grass there would not be finished growing back. It would still be growing because it takes 24 time units to grow back, and we revisit square y 10 units later. So that means it's still 14 units remaining, 14 units of time remaining until it grows back fully. So it needs to be the smallest possible value of x, and that's a little tricky. So in the input format, the first value of x of the first line will indicate n, and each of the remaining n lines contains a single statement and is in the form ds, where d is a character describing direction and s is the number of steps taken in that direction. So please determine the maximum value of x such that Farmer John never steps on a cell with cut grass. If Farmer John never visits any cell more than once, please output -1. So as you can see here, let's start at 0, 0, right? And we're just going to simulate this. So we go up 10, we go east 2, we go south 3, and west 4. And if you look, we just basically do this, right? Kind of looks like a reverse 4 a little bit, but we revisited a square one time. So all we need to do is we need to measure the time that it took to revisit that square, and we also revisit a square again, right? So you can feel free to draw this out, and you'll notice that we revisit the same square once in the beginning, and then the same square another time later in the program. But if we read the explanation, it just says that Farmer John steps on a cell at time 17 that he stepped on earlier at time 7. So therefore, x must be at most 10, or else the grass from his first visit would not have grown back yet. He also steps on a cell at time 26 that he also visited at time 2, so x must be at most 24. Since the first of these two constraints is tighter, we can see that x is at most 10. So as you can see, we're looking for the minimum, actually, not the maximum. So that might have been confusing, but hopefully it clears up once we start programming, which we'll do now. So first we have some static variables. We have n, x, and y. N is just going to be the number of times that Farmer John changes direction. X and y are going to be the position that Farmer John's in, and it's going to be constantly updated. X chords and Y chords, those in array lists are just going to hold every single X coordinate and Y coordinate Farmer John has ever walked through, and time is just going to be holding the time units. So basically, we do everything that we usually do on our main method, and then what we're going to do is we're going to set up our static variables. Just remember that we use in and out to take our input and output to file, and we use the initialize and solve method to initialize our program, initialize our variables, and then solve the actual problem, and then we close our in and out. And then in our initialize method, the n is going to be set up, and then x chords, y chords, and time. And then what we're going to do is add 0 to time because time starts at 0 and then it starts, 1, 2, 3, etc. And then we do a for loop that goes from 0 to n. So we're just going to see what he does every time he changes direction. So we take in s and duration. S is going to be the direction that he goes to, and duration is going to be the time. So if s is equal to n, what we're going to do is we're going to record every single step that he takes. So for A, we're going to just keep adding onto it, right? Because it's a counter, and we're also going to add to Y. So basically, north is, you can think of it as up. So the Y is going to go up. You can think of it like a graph. For east, you're going right, so it's going to be x plus, right? Because if you go right, then the x-axis it increases. Same for south and west, pretty self-explanatory. So all these for loops, they all do the same thing. They're just adding every single x coordinate and y coordinate that Farmer John passes through. So for example, if the first direction change is n10, we're going to add 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, all the way up to 0, 10. Okay. So then now that we have our x chords and y chords array list, what we're going to do is we're going to set up our answer first, and then we're going to, that's going to be the integer that holds our answer. And then what we're going to do is we're going to set up a boolean called meet and set it equal to false. This just, the boolean called meet is it basically just going to check if if Farmer John goes onto a square he's already gone through. And then finally for this for loop, we're going to have it equal to I and less than x chords. And as it increases, we're just going to add time dot add I. So we're just going to, this is just going to be determining how much time Farmer John has mowed for. And it's adding all those numbers to the time array list. So we have this configuration here. This nested for loop is just going to do like a brute force check comparing every single x chord to every single x chord. And if these two x chords happen to be the same, and the y chords the y chords that are linked to these x chords are also the same, then we're going to say that Farmer John does go back to the square he has already gone to. And then what we're going to do is we're going to take the difference, right, between the first instance and the second instance of when he goes to that square, and we're going to find the distance, or basically the distance in time, so how long it took. So if the first time that he goes to square x is time 7, and the second time he goes to square x is time 17, then that means that the difference is going to be 10. So if that difference is less than answer, right? So if that's less than the current answer, then we're going to set answer equal to that distance in time, because we want to find the minimum amount of x that is required for the problem. And remember, x is just the time it takes for a pasture to grow back, or a square in a pasture to grow back. And so that's pretty much it. Now we just need to check if our meet is false. And basically, remember, if meet is false, that means that Farmer John never went to the same square twice. So if that's false, then we're going to output -1, right? And otherwise, we're going to just output the answer that we already have. And now we are ready to submit. So as you can see, we pass every test case, and that is mowing the field. If you have any questions or noticed any problems, please let me know in the comments. If you would want me to do a specific problem, also let me know. Otherwise, thank you for watching.